Welcome! In this unit, we'll be talking about polynomial and rational functions. Polynomial and rational functions are amongst the most useful functions in mathematics because they come up a very large amount of the time. When you get into your calculus courses, one of the first things you'll learn is how to do calculus with polynomial and rational functions. Well, what is so special about these two types of functions? A lot of real-world examples from engineering, physics, business, biology, etc. involve polynomial and rational functions, which is why we're going to spend a particular amount of time studying these. Let's begin by defining these functions. A polynomial function is simply the sum of terms involving powers of x. Here, x is some variable, and the powers, the n minus 1, etc. that you see listed here, are just integer numbers. They could be 0, 1, 2, 3, 4, etc. The coefficients of each term, denoted by the a's here, each coefficient is just some constant number. That constant number could be anything. It could be 2, it could be 7, it could be a half. Those a's are just holding the place of constants. When we sum them up like this, we call that a polynomial. Another type of function we'll be dealing with is rational functions. Rational functions are simply the ratio of two polynomials. So a rational function here, I've denoted as r of x, is the ratio of two polynomials. In the numerator, you have p of x, in the denominator, a q of x. The one special stipulation we want to make is that the denominator should not equal 0. So when we talk about the domain of rational functions, we'll always specify that the denominator polynomial cannot equal 0, so that q of x will not equal 0. Let's give an example of when we might encounter a function that's a polynomial or a rational function. In this case, let's talk about the most popular polynomial, in my opinion, the quadratic equation. Well, a common example that you've probably heard before is projectile motion. In physics, you'll probably take a course where you learn about the projection of a ball. When I throw a ball with a particular velocity, what is the trajectory of that ball? And we'll ask lots of questions like, how long does it take for the ball to fall back into my hand? How long does it take for the ball to reach a certain height? What is the maximum height this ball reaches? Or if I drop this ball, how long does it take the ball to reach the ground? These are all questions that we can answer using polynomial functions. Projectile motion is related to quadratics in two separate ways. One, the shape I get if I take a ball and I launch it at a particular angle with a particular velocity, that ball moves in what we call a parabolic orbit or a parabolic trajectory. So it kind of looks like a parabola. Another relationship is that when you drop a ball, the speed of the ball is such that the position of the ball as a function of time satisfies a quadratic equation. Namely, the position is related to time squared. So if I drop this ball, the position would have been a function of t squared. In general, there's a physics equation, h equals h0 minus 16t squared. This equation is the equation for a ball dropped, or any object dropped, from a height h0 falling under Earth's gravity. That 16 you see there comes from the equation for Earth's gravity, or namely the gravitational constant on the Earth. And this one happens to be in feet as our measurement. Let's do an example problem. Suppose we drop a ball from a height of 200 feet off the roof of a building, and we want to know when that ball will hit the ground. Well, using that equation from physics, we can set up the equation h of t equals 200 minus 16t squared. And since I want to know when it hits the ground, I want to know when the height is 0, because the ground is at the bottom, so I set that equation equal to 0. Let's go ahead and solve this equation. I'm going to move all the terms involving t to one side and all the constants to the other side. I get 16t squared equals 200. Now if I solve for t, I can divide both sides by 16, and I get t squared equals 200 over 16, or I can simplify that to 12.5. Finally, if I want to get t by itself, I know t squared is 12.5, so t must be the square root of 12.5, which if you bust out a calculator here, that's 3.54 seconds. You might be asking yourself, well, when I take t squared equals something and I take the square root, don't I get a plus or minus? You're right. Normally you would say plus or minus the square root of 12.5, but because here t represents time, time can't be negative. So we'll only be talking about the positive values of time, and that's why I just picked the positive 3.54 seconds. So there's an example of how we would use a polynomial, in this case a quadratic equation, to solve for an important information from an application problem. Let's move on. What are you going to learn in this unit? Well, in this unit, you'll learn several skills involving polynomial and rational functions. Namely, you'll learn to solve quadratic equations, which you probably already encountered in this course earlier, but here we're going to be focusing on three main techniques. You're going to be solving quadratic equations by factoring, something you've already played with a little bit. You'll also learn a technique called completing the square, and you'll learn how to use the quadratic formula. Another thing we'll be doing is graphing and working with these graphs of quadratic functions, namely parabolas. So you'll be learning about what happens when you transform the graphs of parabolas and how to find the vertex of these parabola graphs. Another thing we'll be learning to do is performing polynomial long division. Polynomial long division is a useful skill that will come up later in calculus. At this point, it may not seem clear to you why this is a wonderful, useful skill, but trust us, this is a pre-calculus course, and we're hoping that this skill will come back and help you later. Another thing we'll be learning to do is performing arithmetic with complex numbers. Complex numbers are things involving I, or the square root of a -1. That's called an imaginary number. So we'll be dealing with how to do arithmetic, add, subtract, multiply, and divide, numbers involving those complex numbers, namely square root of -1s. We'll also learn how to work with some rational functions. We'll be able to find their asymptotes and graph rational functions. We'll also be talking about how to solve polynomial and rational inequalities. You've already worked a little bit with polynomial inequalities when you dealt with linear inequalities. Now we'll learn how to deal with it when there's higher powers, such as quadratic parts. What are the applications of these rational and polynomial equations? There's a lot of examples. We already saw projectile motion. For those of you interested in the business world, a lot of profit equations involve quadratic or polynomial equations, and you'll very often want to learn how to find maximums of things like that. And if you know the graph, it's very easy to find a maximal term for something like a profit function. Another thing that comes up a lot is manufacturing. When you're trying to make boxes or containers for things, you want to minimize the amount of materials you use and maximize the amount of space available for your product. This is an example of using polynomial functions. There's a lot of polynomial functions that come up in other areas. If you skim through your book, you'll see examples of applications to physiology and muscle contraction, shooting of a basketball, and all sorts of other examples like that. Well, I hope you enjoy learning about polynomial and rational functions. Thank you, and I'll see you next time.